AC sine waves.
Alternating current is the most prevalent type of electricity worldwide, as it is commonly used in households and electrical appliances. The usual waveform of AC is the sine wave. Here is a blank diagram of an AC sine wave. First off, we have the wavelength, which is the distance between two consecutive peaks or troughs. The equilibrium is the point where voltage equals zero, as the wave has balanced out. The amplitude is the peak voltage and is the maximum voltage of an AC sine wave. This here is the peak-to-peak voltage, which measures from the highest peak to the lowest. The period is the time it takes for the wave to complete one oscillation. Here is the root mean square value, or the effective voltage. It is the equivalent steady DC value which gives the same effect, as DC. The y-axis of a sine wave is measured in volts, and the x-axis is measured in time, sometimes in terms of pi. And there we have a final diagram of an AC sine wave. Here is an example of what an AC sine wave can be represented as in the form of an equation. The d, the DC offset, tells us how much the AC sine wave is shifted on the horizontal axis. The amplitude, which can be denoted as A or Vm, the frequency f, and the phase, as theta, which shifts the wave on the vertical axis. Equations relating to AC sine waves include frequency equaling 1 over t, the period, lowercase omega equaling 2 pi over the period, which also equals 2 pi multiplied by the frequency. The power of an AC component is Vm sine lowercase omega t times Im sine lowercase omega t minus theta, similar to a DC circuit's P equals Vi. The RMS, or the root mean square of voltage, equals Vm over square root 2, and the peak-to-peak voltage is equal to the magnitude of the positive peak voltage plus the magnitude of the negative peak voltage. The average value of an AC sine wave comes from adding up the area of the curve over one oscillation. Anything above the x-axis is positive, here being positive 2 volts, and anything below the x-axis is negative, in this case negative 2 volts. Adding these together, the average value is 0, which is common for AC sine waves with no DC offset. And there you have it, the basic characteristics and features of AC sine waves.